this lid type of lock that you could see in the picture out here and over here. This is the common mode of closing a particular door or a window in most of the places in the rural India, or the places where too much of cost is not required in the places. So our idea was to redesign this particular thing that can be used as a digital lock, and we could control it wirelessly. So the meaning of wirelessly is that we didn't want anyone to touch this particular thing to open the lid. The reason is, since we all are aware of this COVID-19 feature, and that most of the people, not only over here, in the places where the humans are in a very common, you could say, quantity, let's say in the public places. I was talking about this lid system. We use our hands to touch it and open the lid front and back to open the door. So the main idea was to redesign this particular thing using digital means, so that less human interface is required while opening and closing those lids. So we came up with this particular design using a motor and a wireless RF communication. So what are the key features while using this touchless lock? Basically, we have been using two platforms, as I told earlier also. We have been using the Arduino board and the RF transmitter receiver boards. So the Arduino was selected because most of the people in places are not aware of programming. Let's talk in general. I would say many people know it, but in general, most of the people think that programming is a very tough thing. So Arduino is the only source I found that is cheap enough, so that not much of coding is required, and we could just modify a few lines of a ready-made code, and we could build up this particular project. So, and the cost, definitely I'll go on with the bill of materials in the end of the slide. So the exact cost of this entire project came out to be less than 1100 rupees. Fine. So that's not a big deal. So we are even to the study to make it further down, reducing some of the components, and we'll get to it later on. So let's begin with the task. So these are the steps that are involved in building the touchless lock. First, we'll be understanding the concept. Then we'll be moving forward to the procedure for hardware assembling using the transmitter side. Then we'll move on to the procedure for assembling the receiver side. After the hardware interfacing is done, we'll be coding our Arduino Uno board using the Arduino IDE. Those who are not familiar with Arduino or its coding, I'll be going through the basic steps of how to write a code, or how to basically debug a code and compile and verify it, along with uploading of that code on the Arduino board. Finally, once our entire board is programmed, we'll be testing it to check on whether that particular code is working as per requirements or not. Last but not the least, we'll be going to the question and answers. Whatever questions you have in your mind, we can put forward in the end of the slide. Okay? So we start with the assembling of the transmitter side. So what does a transmitter basically comprises of? Our transmitter section comprises of is an Arduino Uno board, one ADXL3325 accelerometer module, and an ST12D ST12E encoder IC, along with an RF transmitter module. So I use these three components basically to comprise my transmitter section, and we'll be using a battery, or you can use a USB cable to connect to your Arduino board to power it up, and the rest of the circuitries. It's up to you. For testing process, we basically used a USB cable to power up the Arduino board, and those of you who are new to Arduino, or those who are not that much familiar to Arduino, I would just go briefly with the key points of it. So Arduino Uno is an open source platform board that has inbuilt libraries, inbuilt sketches that can be downloaded from the internet, and you can modify those sketches and reburn them into this microcontroller on the Arduino board using a USB cable. It's very simple, very easy. I'll show you in the end. So you can power up the Arduino using the USB, or you can power it up through the DC jack. Along with that, you can see the number of pins out here. These are the digital input-output pins that can be used to interface any digital component, let's say an LED, motor, relay. anything or switch, any sort of those things can be connected to any of these pins as per our requirement. Similarly, we have the power circuitry out here where these pins are for the power section. We have a 3.3 volt power, 5 volt power, and ground pins out here. So whenever I'm going to use my Arduino board in any of the projects, I can simply connect a USB cable to it, and I can use these pins out here to use 5 volt, 3.3 volts, or ground from these pins to any other circuitry. Similarly, these are the analog input pins available in this Arduino board that can be used for taking the analog inputs. So I'll be basically using these pins out here and two pins out here. These pins I'll be using to interface my ADXL335 to the analog input pins. I'll be using these 6 pins and interfacing it out here. In the program code, I'm going to mention what these particular pins have been used for or they have been configured for. Similarly, I'll be using pins out here to connect to my ST12E IC for transmitting. So ADXL335 is an accelerometer that's quite using its it has been used in quite a number of applications, some of them being the gaming or the gesture controlled projects. It's very easy to use it since we can see we are having the 3 axes made out here, X, Y, Z, X, Y, Z. So we can just clarify on the x-axis, that is the tilting of this accelerometer module. We can see these capacitors out here, X, Y, and Z, these small capacitors. So we are talking about these capacitors that they are used to select the bandwidth of the accelerometer. So we can define the bandwidth range of these accelerometers, and based on those bandwidths, if this accelerometer module is tilted in the left, that means X direction or Y direction or Z direction, we get some changes in these capacitance. Based on that, we are getting some analog inputs that can be fed to any of the analog pins of our these pins of our Arduino Uno board. So this is how we mounted our accelerometer module on our Arduino Uno board. In the image you are seeing a Freeduino board, so it's basically a copy of your original Arduino board since it's an open source platform. So we have basically copied it and made our own this Arduino board and renamed it to Freeduino board. It's basically from Technido company. So we have also modified it and made our own board also. Finally, you paste or you basically embed this accelerometer module on your Arduino Uno board, and you have this this transmission module as I have made out here. I've used an ST12E encoder IC, a resistor. This is my RF transmission section, and this is the antenna. You can use a long wire also instead of this antenna what I've used out here. So you can use the long wire also for this. Okay. This is the basic connections of connecting your ST12E with your RF transmission. You can see there are 4 pins: ground pin, data pin, VCC, and the antenna. So the ground pin has been connected to the ground section. The data pin has been connected to the D out pin, that is pin number 17 of ST12E, while the VCC is connected to pin number 18 of your ST12E, that is VCC. For the antenna, I've connected a wire to it. Okay. So the main function is whatever parallel data, whatever data I'm going to get from the Arduino board, or that is going to be fed to your ST12E. Like I said over here, see, this accelerometer module is going to be mounted on this Arduino Uno board. Whenever I'm going to tilt this entire Arduino board along with the accelerometer module in X direction or Y direction, it is going to make some changes in these capacitance values. Based on those changes in the capacitance values, the accelerometer module is going to feed some signals in the analog form to these pins. Those analog signals being received by these pins are pre-fed with some code in the Atmega module, Atmega microcontroller over here. The microcontroller has been pre-programmed to make some changes in its digital output pins if it receives some input at its analog input pins. Whatever values I get in the X or Y axis out here, that has been configured in this to take some action through these output pins. And those actions are being fed to this HT12EIC in the parallel in form, these 4 pins, parallel data in forms. As you could see, I showed here, this parallel data in forms. These parallel data input from the Arduino is fed to the HT12EIC, and then it provides me a serial data out through pin number 17 that is fed to the antenna. That serial data is serially transmitted through here. So this is for connecting the wires. As you can see, these pins, I'm talking about these particular pins and this accelerometer module. Oh, I'm sorry. I was talking about the HT12EIC and the Arduino board. So in the Arduino board, pin number 8, 9, 10, and 11. It's up to you. If you're using 2 DC motors, you can use 4 pins. If you're using just one DC motor, you can use either of these 2 pins, pin number 8 and 9, or pin number 10 and 11. So in my code, I've used pin number 8 and 9. So 8 has been connected to D3, that is S4. You can connect, these are the 4 pins that are configured here as S1, S2, S3, S4. So I'm connecting my S4 to 8 and S3 to 9. S4 to 8, these S4 to 8 and S3 to 9. Normal VCC ground, you have to connect to the VCC and ground pins. So after the connections and the mounting of the accelerometer module on our Arduino board, this is what we get. Basically, this is the arrangement that we made. So we used a USB cable initially to power up this Arduino Uno board, and you can even mount this on your hand, like that means your wrist. You can use a adhesive tape to mount this thing on your wrist, or you can use a wooden board or a plastic board, and you can stick both the components on it using a hot glue. So it's totally up to you how you are going to use this transmitter section. Receiver module. So basically, this is the section we can consider for receiver module. So this is the receiver of your RF transmission reception section. This receiver module is connected to HT12D IC, that is the decoder IC. Over there we had used the HT12E IC. This one, HT12E IC, that is encoder IC. In the receiver section we are using HT12D, the decoder IC. So whatever data that is being captured by this RF transmission receiving section, that is the receiver section through its antenna, that data is moved out from the D out pin, that is this pin, pin number 2, D out pin, to your input of HT12D IC. So that serial data from the receiver is fed to HT12D, and that is again broken down into the parallel data format, that is D0, D1, D2, D3 internally through this HT12D. We don't have to do anything. The only thing is this is going to receive the data. That serial data is going to be input to the HT12D. That HT12D will automatically convert that data into parallel form, and we can get those 4 bits from D0, D1, D2, D3 from these 4 pins. So we are going to take the data through this receiver module, feed it to HT12D. From HT12D, I'm just using 2 bits. So those 2 bits I am using to my L293D motor driver IC. So as you all must be familiar, for driving a DC motor in digital applications, most of the times we are using a motor driver IC, that, and the common among that is the L293D. So as you can see from the pinout diagram, at the most I can connect 2 motors. Like one motor I've connected to pin number 3 and pin number 6. Similarly, I can connect one motor to pin number 14 and pin number 11. But in my application, I had used just one motor. So I've drawn in this diagram at pin number 3 and pin number 6. So whatever input I'm taking from HT12D is being fed to your L293D, pin number 2. Similarly, the other bit is being fed to pin number 7 of L293D. Just have a look at this diagram. So I'm getting two bits, one at pin number 2, the other at pin number 7. Those two bits can be 1 0. That means a motor will move either clockwise, or it will be 0 1. The motor will move anti-clockwise. So based on the values that I'm getting over here, if it is 1 0, the motor will move in clockwise direction. If it is 0 1, the motor will move in anti-clockwise direction. So this is the simple funda that we used out here. We'll get some signals at the RF receiver section. The RF receiver section will forward it to the ST12D IC. The ST12D IC will forward it to the L293D motor driver IC. That motor driver IC is going to drive the motor. Okay. Now coming up to the mechanical parts section. As in the image you saw that we are using the DC motor, but this particular mechanical arrangement is to be made. We have not made this mechanical part. So what are the tools you are going to require for this particular mechanical arrangement? You'll be needing a marking pen, and you'll be needing a hot glue gun. These are the only tools you'll be requiring mostly. Yes, definitely a screwdriver set also. A DC motor of 100 RPM, 9-volt battery with connector cap and connecting wires, nut and bolt 2-inch length and size, door stopper arrangement with lid. You can use a wooden or a plastic block. Like I mentioned over here, you can use either a wooden block or you can use a plastic, whatever material you feel like. Or you can even embed this thing particular inside a wall. So it's up to you how you want to make this latch arrangement in your door. So you can use the material specifically. And you might be using an unused syringe. I'm again specifying it. Do not use a used up syringe cap out here. We need a new one, because a used one would be basically it will be having some harmful things. So it's better we use a new cap of the syringe. Then the ST12D IC, the receiver section, and L293D motor driving module. So you can use this ready-made module, or you can make your own module also. It's very simple. You can find the videos on our YouTube channel also. Let's work on the receiver section. The first step is you need to mount the door stopper sled on the wooden block. So you can basically place and make a marking through a marker on these particular 4 holes. You can use a marker, make 4 holes out here, so that you know exactly where to drill for putting up the screws. Second step, you remove that sled, use an electric drill machine to make the drilling at the particular points that you have made. Third step, you place the lid back and you screw it up on the 4 markings and the drilling that you have done. Finally, you see it that it's tight enough that it does not come out from the wooden board or the plastic material. Next, you can use an adhesive. In our case, in our lab, we used an M-seal. That's basically a mixture that is joined for pipes and tubings. So in mostly sanitary applications, but in our case, we had to join a bolt. So we use it a good stuff. So you can purchase it from the market. It's very cheap, and you can mix it up to make a paste that can be seen in the figure out here. So basically that paste is molded on the bolt that we had, so that it is able to fix it up on the, see, we have used that M-seal on the bolt and fixed it up to the lid, that lid, so that it's tightly bound. So it does not remove from here. You can additionally use an adhesive like Fevi stick and all those things. And then you can use this M-seal material so that it does not move out from here. Then you need the nut or the screw. You need to screw it up a bit so that it gets fixed up inside this. Now we come to the needle. Take out the needle, throw it away in the dustbin. You simply need this cap. We are going to cut this cap from here and use it for attaching it to the DC motor notch here, so that this screw easily gets fixed up and gets fixed to this DC motor. This way, see, we use that syringe cap, cut it down, and we pasted it into the shaft of the DC motor. and then that screw that we had screwed it up to this particular arrangement, we pushed it a bit so that it fixes it up inside this DC motor. Now it's a single entity. Whenever the DC motor is going to rotate, this screw is going to rotate either in clockwise direction or anti-clockwise direction. You'll be needing batteries to power up this particular section, the motor and the circuitry out here. So this is one of the designs we found on the net that can be used as a digital lock arrangement. We can bolt it up like they've shown in the image. Similarly, you can do it in your home also, or your office, or whether applications wherever you want. Okay, for those of you who are new to Arduino, this is how we are going to start up. You need to download the Arduino IDE from the Arduino website. I'm having this Arduino 1.0.4. That's not the latest one. You can download the latest version from the internet. So once you've downloaded it and you open up the folder, you get this particular executable file. You need to double click on this executable file to run the Arduino. It will show something like this. That's opening the Arduino. Then you get this particular window opened up. This is the first window that opens up whenever you run an Arduino IDE on a laptop or desktop. So I'm just elaborating these points. The shortcut keys out here have been elaborated over here. This tick is used for compiling and verification. The right arrow is used for uploading basically. That means whenever you want to upload your code to any microcontroller on the Arduino board, you will be using this particular button. New sketch. You want to make a new, basically I would clarify again, by sketch I mean a program. In normal languages coding, we use a program to write something. While in Arduino, we don't use the term program, we use the term sketch. So for writing a new sketch, you can use the shortcut. You can open an old sketch using this particular shortcut as shown here, and you can save this particular sketch by using this shortcut here. All right. A basic example you can check, like those of you who don't know coding at all, you can go to the file menu, go to the examples, and over here there are numerous examples available for you. You can use basics, digital, analog, communication, whichever you want to just study more. You can go on for that. In the simplest case, you can go for the basics and the blinking of an LED. Once you click on that, this particular code will open up where they've specified the code. You can see the code is so small. We are having inbuilt functions, the setup function, the loop function. I'll tell you later on how to use them. And simply we have defined the LED pin number 13. So it's very simple. You need to verify it, upload it. That's it. It's going to compile and it's going to display on your Arduino board how that LED is blinking. So it's that simple. I'll go through again. File, examples, basics, blink. Once the program opens up or the sketch opens up, you can verify it or compile it, and then you can upload it. After uploading, you can see that your program is running. Yes, definitely few steps I messed up. Before that, you need to go to tools. You need to select your Arduino board. Like you might be using an Arduino Uno, you might be using an Arduino Mega, you might be using an Arduino Micro. So whichever board you have got from the market, whichever you're selecting, you have to select the board from here before uploading. So in our case, I have selected an older version. So I selected Arduino NG or older. You can use Arduino Uno. It's up to you. Then you need to select the serial port. Like by default, whenever you connect your Arduino using a USB cable to your laptop or desktop, a COM port is assigned to it. So you need to clarify which communication port your Arduino has been attached to your laptop or desktop. So that comes out under tools, serial port over here. You can see the communication port. So as I said, after that we need to verify. It will show you done compiling. It will tell you the size of your program code or your sketch code. Upload it. Once you upload it, you can see that the Arduino board is mentioned over here and the communication port is also mentioned over here. Okay. So very simple, go to file, go to basics, open up a new sketch, verify it, compile it, and then upload it. You can see it running on your board. Now coming back to ADXL, similarly you can test for the ADXL module. Go to file, examples, sensors, ADXL 335. You can select from here. You get this particular ready-made sketch of ADXL 335 module opened up. From here, you can make slight changes as per your requirements. Like I'll describe it later on the code. There I'll specify more. Again, you're having the setup function and the loop function. Just keep in mind, friends, there are just two functions to be used in Arduino. One is the setup function, the other is the loop function. This is the only two functions we'll be using most of the times, unlike our C language or any other language. Again, you can verify, you can compile it. Once it compiles, you can see this green bar, it finishes up till here. If it is having some error, it will point you out here, whatever errors it has. If there are no errors, it will not show you any errors and it will complete. For seeing what your serial data, what your accelerometer module is picking up, you can click on the serial monitor window over here and you can get a window like this. So over here you can see the x-axis parameters, the y-axis parameters, and the z-axis parameters. So whenever you are tilting your x, y, and z of your accelerometer module, these values are getting changed instantaneously. You can see it is 363, next moment it was 380, then 364. So they're randomly changing based on the capacitance values on those accelerometer modules. So like I told you, the x analog pin of your accelerometer module is picking up some values, and our task is to define a particular bandwidth or a particular range. So we want a particular range. Let's say if it is showing 363 as the most common value, I define a range from 360 to 370. So if my this accelerometer module tilts and gives me a value of 360, that is my minimum value. If I tilt it backwards in the x direction, 370 is my maximum value. So anything in between, that accelerometer module is going to sense. But anything outside those two values, the accelerometer module will neglect them. It's not going to read those values. Same is the case for the y-axis also and the z-axis. So as I told you in the beginning, basically we will be using a DC motor, 9-volt battery, nuts and bolts, door stop arrangement, wood in a plastic block, empty plastic cap or medical unused syringe cap, ST122 IC, RF receiver module, L293D module. These are the receiver section components. In the transmitter section, we need an Arduino board, ST12E IC, RF transmitter module, and a 9-volt battery along with some wires. So the approximate cost of the entire project took us somewhere around 1039 Indian rupees. Well, if we are into some modifications and we'll try to get this down to less than almost 500 rupees. So the work is going on. Once this COVID thing happens, it's over, we'll try to get back to our lab and work on it. Working and testing procedure. So this is the small video. It's just a copy of the original video. You can see it. So as I told you about the code, so the code is quite simple. In our case, we have used the 5 pins of the accelerometer module, that is pin number 18, 19, A1, A2, 3 of the Arduino board. For your clarity, I'll just open up side by side so that it's easy for you. Okay, I think we are getting out of time, so that's it.
Have you used free Arduino instead of Arduino? What did you do for the programming part?
Okay, see, we can use Arduino Uno board. It's not mandatory that we use a Freeduino board. Freeduino is just a copy of the Arduino board. So you can use both and the code remains same for both of them. It's not going to be a difference in the code.
What is the different programming language that can be used in this Arduino?
Okay, Arduino is not having any different programming language. You need to write in the Arduino IDE itself for burning the code in that Arduino board. You cannot use a separate programming language, and it's very simple. There are some tutorials you can get it. Even I can share with Ashima those tutorials. They're very simple. Few line of codes you will get through them once you are familiar with the setup function and the loop function.
Sir, one question is, can we use Arduino board or its copy for commercial use?
Sir, I would like to answer like instead of using the entire Arduino board, you can simply program the Atmega microcontroller or the Arduino and then take it out from that Arduino board and use few components along with that. You can use it for commercial purpose. Using an Arduino for commercial purpose, maybe it will be basically a bit costly. Like I told you, the cost is coming somewhere around 1039. So in order to reduce the cost, it's preferable in commercial. Do not use Arduino as a whole. You simply use the controller on it and the few components required for it.